to the Jenka hardness. This is one that's been a real seller for a lot of retailers, trying to get a product, harder the floor, the better it is for my dog. And, we start getting into is where's the performance going to be on my floor? We get into two things on this. Is number one, when we look at far as in the Jenka test itself, it cannot be done on an engineered product. Simply is when we're pushing this placement of the ball and it's pressed, when you look into the halfway to the plank, what are we pressing it into? We're pressing it into either an HDF core, birch core, lumber core, but it's not of oak or maple or birch or Ipe or whatever the low mellow material is. So this test here cannot be used for doing on any engineered floor. The second thing is when we're using that Jenka scale about hardness for a customer, and we're going to be dealing with over radiant heat floors. The one thing you want to keep in mind that woods above 1375 may not be a good candidate for radiant heat floors. So when you start looking at maple, hickory, Ipe, kumaru, those are beyond in the Jenka scale being upward. They don't have enough elasticity for that sudden shock of going in and out. So that means that in those, they may end up having more issues with splitting and cracking with that higher Jenka rating. So when people are looking at, I want to have hickory because it's harder, but I got radiant heat, most likely it's not going to be warranted by the manufacturer. Two is because of the species, it's most likely going to have issues with splitting and cracking. Another one is testing locations. It's a quick check. I don't know, this one here, I think I paid 50, 60 bucks for it on Amazon, but it will tell you exactly where your supply temperatures are. This is something that'll go also, it'll tell you your maximum, as well as, here, I got a maximum 86.5, but a lot of these is important to have that check when you're doing install of a radiant, to make sure that you were in spec at the time of install, that it was within the standard of the manufacturer, as well as being able to do an inspection later if it came out on a job site. Going on a radiant heat system, I want that system up and running for 48 hours because this is exactly what I want to check what their supply temperatures are to make sure we're within spec. And the first thing I'm going to check back is I'm going to peel back their rug area to see exactly where my temperatures are. Here when we start looking at some of the side effects of radiant, we're going to see here, for example, you're going to see end gapping. When we start looking at end gapping, does anybody know why we see end gapping on engineered products?
The way the overall core is expanding and contracting with the product.
The way the overall cores are expanding and contracting with the product. That'd be correct. Now, if, for example, if I was taking, we're going to get out of engineered flooring and just go strictly plywood core. So if we looked at, for example, I'm going to say, let's say we had a piece of plywood that was 8 foot by 8 foot, and it's going to go back by your 1 inch dimensional change. So you'd have your dimensional change per inch, whether it be in width or length. Because the product is absolutely square, you're going to find the expansion and contraction will be equal both in width and in length. So when you start looking at having a product that's going to be in an engineered plank form, or even like a 4x8 sheet of plywood, it's going to expand and contract twice as much as in the lineal than it will in the width. Now let's take a 4 inch wide by 48 inches long. Now even though it's an engineered product, we see very minimal side gapping, but we're going to end up seeing end gapping for that reason, because of the way it's dimensionally produced. And cycle, and that's where we find where the customers will come out and say, oh geez, installer didn't put up the floor, knock up the floor tight. It wouldn't be patterned this equally throughout the entire floor if it was installer related. You go back to a seasonal, we'll take a look at it, and a lot of times I hear mistakes that retailers or manufacturers will make as, well, it's got a 1 year warranty, we'll look at it in a year. No, I want to look at it when we have humidity cycling change. That might be in 3 months, 6 months, but I want to be back when we got full humidity, because I can guarantee you those end gaps are going to be gone. It would show now it's environmentally controlled of a reason for failure rather than being for install or manufacturer related. The same thing that'll happen in your planks and your side gapping. And we talked earlier about having those planks that showed through that hickory 5-inch plank where it changed in width from spring to winter. And here you're seeing, in this case, of the floor where you're seeing, all of a sudden you're seeing the side gapping that's occurring in the plank floors. It's the same thing in relationship of being with our dry environment over radiant heat, that it's going to react faster over radiant heat and for a longer period of time. For example, like with us right now, just into the heating season, with our forced air systems, we haven't put really a lot of stress on our wood now in the house. On a radiant heat system, that stress started the minute that heat went in, because you've got the heat source right on the floor. So on our forced air system, we'll start seeing gapping. My gapping claims will come in probably in the next 5 to 6 weeks. We'll start seeing it because people are not watching their moisture control. Where radiant, it'll come a lot quicker because of the heat being that close to the floor. So when we look at like here, this is a good one I like on this, on the end gapping here, and we discussed why that is and where it's consistent. And the face checking, I know that this is one that it's important to know when we're dealing with new construction and how that we're actually dealing with floor cover, because you're going in, floors are going to be installed, they're going to put the floor cover down, and the next thing is we have to sit there and try to, and we're still under warranty on what's happening with that floor. Even if we ended up putting humidity into that house, even during the construction, just even from painting, and we got a floor cover on that floor that does not breathe, that's going to end up affecting that floor, especially on radiant. You're going to see it shatter just as the way you see it here now. So it's really important to know when you're dealing with whatever floor cover is specified that it has the ability to hold out topical water, but has the permeability to allow the vapors to still come through. And that's the part, whenever we're specifying or looking into our floor cover, it's important to understand what those products are. I know some products advertise a great deal of water holdout, but their permeability really sucks for vapors when it's dealing with RH and keeping wood moisture.